Energy in physical and chemical change. What is energy? Energy is basically defined as the ability to do work. If you have energy, you will be able to do work. If there is no energy, you will not be able to do any work. As simple as that. Energy is the ability to do work. There are multiple forms of energy that exist, but we majorly classify into two major, very broad categories. The first one's called potential energy, and the second one's called kinetic energy. What is potential energy? Potential energy basically comes from this word potential. If I say you have this potential, which means you have it in you. So that's exactly what potential energy is. Potential energy is the energy that is stored in substance, in any given substance. This is the energy that is stored. That is called potential energy. Okay. Then you have another term which is called kinetic energy. Kinetic energy comes from the word kinetics. Kinetics basically means motion, speed. Okay, so kinetic stands for motion. Kinetic energy is the energy of motion. When anything is not static, it's moving, that is called kinetic energy. The faster the object moves, the more kinetic energy it has. The slower it moves, the lesser kinetic energy it has. That is the difference between these two forms. Okay. Now there are multiple other forms of energy. For example, there is heat energy, which is also called as thermal energy. Energy because of the high temperature. Higher the temperature, more the heat energy. Another energy is mechanical energy, right? The energy that is present in machinery. Then there is energy, electrical energy. The energy that is due to the electric current, that is called electrical energy. So there are multiple forms of energy, and important thing to remember is all these forms can be converted from one form to another. Meaning, this brings you to law of conservation of energy, which simply tells you that energy is conserved, meaning energy can neither be created nor destroyed. You can't make any new energy, you can't destroy any new energy. Energy of this universe is basically constant. Only thing we can do is we can transfer the energy from one form to another. For example, when you run your car, okay, how does your car work? You get gasoline, gas has what? It has potential energy stored in it. When it burns, it basically produces energy. All this potential energy converts into, let's say, mechanical energy. So your mechanics and machinery can run. When your mechanics run, your mechanical energy is then converted to kinetic energy, because of which your car is now in motion. So that is how energy changes from one form to another. How are you seeing those light bulbs working? There is electrical energy that comes from the socket, goes to your light bulb, and it converts that energy into light, which is also a form of energy. So basically the idea is that energy cannot be created, it cannot be destroyed. Energy amount is fixed, it only goes from one form to another. Okay. For example, Earth, we get energy from the sun, the ultimate source. How is the sun getting energy? There are nuclear reactions that are occurring in the sun that gives sun energy. That energy reaches Earth. On Earth, that energy is absorbed by plants. Plants convert that energy through photosynthesis into food. They give us fruits. This food is consumed by humans, and humans get energy, and humans use that energy to basically do bunch of different work, bunch of different processes. For example, we are breathing, we are talking, we are sleeping. All of that requires energy. Okay, so energy is going from one form to another. This is showing you heat energy. Heat energy is basically a type of kinetic energy. It is also kinetic. Why? Because how does heat energy work? When you heat any substance, meaning you increase the temperature. If you increase temperature of a substance, atoms absorb energy. All extra heat that you give, they absorb. When they absorb energy, they are very energetic and they want to move around. So atoms want to continuously move around. They want to move more. When there's more motion, there's more kinetic energy. So higher the heat energy means more kinetic energy, because the atoms are more in motion now. For example, if your room suddenly starts to get hot, what's the first thing that we do? We start moving around, right? Because now there's more heat, so our molecules, atoms, everything has more energy, so we are feeling more hot. So everything's moving around, kind of like that. Think it in that sense. Atoms are also gaining energy. They're feeling hot, so they're continuously moving around. Okay, when they move, that means kinetic energy. There are units of energy that are used. One unit of energy is calorie, commonly used unit, calorie, which is written as small cal. Okay, calories. What is calorie? It is defined as the amount of energy needed to raise temperature of 1 gram of a substance of water by 1 degree Celsius. Okay, 1 calorie is equal to 4.184 joules, another unit for energy. Joules, kilojoules, these are different units of energy that are also used. So you can see joules, kilojoules, small calories, or capital calories, or kilocalories. These are all different units that are used. The capital calorie that you see, that's not a unit of energy, that's actually a unit of nutrition, nutritional energy, right? When we say food, we say how many kilocalories you have eaten. That is what we are talking about in capital calories. Okay, this is basically small calories, written in small. Now, why do we care about energy in chemistry? Whenever there is a physical change or a chemical change that occurs, there is always energy involved in that process. For example, physical change, if I take water, it's, let's say, liquid, I heat it up, it turns into steam, which is a gas, which means there is heat involved in this process. So it's a physical change, but there is energy involved. Similarly, in chemical reactions, for example, when carbon burns with oxygen, it gives you CO2 and it gives you a big flame. Okay, what is this? This is carbon, basically means coal. Coal is majorly carbon. So when this reaction occurs, it gives you a lot of heat and lot of light that is produced, right? All of that is again involving heat. Chemical change, physical change, they all involve heat change. That's why we are interested in energy. Okay. One important thing to remember, this is again explaining you, a tree grows by absorbing energy from sun to convert carbon dioxide and water into plant material. So it stores energy, right? But when you burn this tree, if the tree catches fire, that releases all the stored potential energy as heat and convert the plant material back to carbon dioxide and water. So everything's basically converting back to its original state. That's what this means. You can only change form. Okay. Coming back to energy, remember that whenever any substance has high energy, that means it has less stability. Okay, for example, if you think of like kids, right? Kids, when are they more stable? When are they more quiet? When they have less energy. When they have more energy, they are continuously running around, right? That's kind of very similar. It's like an analogy. Take it as an analogy. For example, when molecules have more energy, they are unstable. High energy molecules are usually unstable. They have less stability. But when the energy is low energy means molecules are moving around less. That is when they are more stable. Stable molecules or atoms. Okay, that's how energy relates to stability. Now coming back to reactions. Okay, how is energy involved in a reaction? During a chemical reaction, if heat is produced or heat is released, depending on that, we can classify the reaction as either exothermic or endothermic. Okay, the word thermic comes from the word thermal, which means heat. So thermal here stands for heat. The word exo comes from the word exit. Exo means exit. Heat is exiting the reaction, meaning heat is released. If during a reaction heat is released, that is exothermic. Endo comes from the word enter. If heat is entering into the system, meaning heat is absorbed by the reaction, that means it is endothermic. That is the two definitions we use. Many chemical reactions absorb or release heat. An exothermic change is the one that releases heat. Example, burning of wood. When you burn wood, it produces a lot of heat. You sit around it and you absorb that heat, right? That is an example of exothermic. Changes that require energy to occur are endothermic. They absorb energy. For example, when you want to convert water to steam, you have to give heat, you have to add heat to water. That is endothermic. Okay, so for example, when this fire burns, it produces heat, so it's exiting out of the system, exo. When water boils, you have to give water the heat, so it is endo. This is showing you another exothermic reaction. Exothermic means if this is my reaction, the heat will go to my surroundings. Okay, if this is my reaction, the heat will be absorbed by my surroundings. Usually, how does it work? This is my reactant. This is the energy of reactant. If let's say this is the chart, a graph where potential energy is increasing as we go up in this chart. So reactants have more energy, products have less energy. That is why when reactant turns into product, all this extra energy has to be lost energy. And how will they lose all this energy? It is usually lost as heat. That is why it's exothermic. Whereas in case of an endothermic reaction, for example, a cold pack, right? Cold pack, if you shake it, that is an example of an endothermic reaction. It absorbs heat from your body, so you feel cold. That is endothermic. In case of endothermic reaction, if this is my reaction, it will absorb heat from the surroundings. Heat enters into the system. Again, if you look at based on the graph, if this is the increasing potential energy, the energy of reactant is low, energy of products is high. That is why when reactants turn into products, they have to absorb more heat. Heat enters into the reaction. Then only reactants can turn into products. So that is endothermic.